Chapter 8, Section 1, The Size and Scale of the Universe. Digging deeper. Your place in the universe. Measurement in space. You just investigated the very large distances between objects in space. Generally, there are three major scales at which scientists study parts of the natural world. At the first scale are those parts that are directly observable and can be seen, touched, felt, or manipulated. For example, rivers, glaciers, and rocks at the surface are parts of Earth that can be easily observed and studied. At the second scale are those parts that are too small to be observed directly, such as atoms, which cannot be seen individually. Finally, there are those parts that are too large to be observed directly, such as planets, stars, and galaxies, and the extremely vast distances between them. To help you understand the magnitudes of space in the solar system, you tried to make a physical scale model of the solar system. To do this, you needed to know the distance of each planet from the sun. Astronomers often study objects that are far from Earth. As you saw in the Investigate, it is difficult to use units such as kilometers to describe these large distances. Even 1,000,000 kilometers is too small of a unit. Astronomers solve this problem by using larger units to measure distances. When discussing distances inside the solar system, they often use the astronomical unit, or AU. One astronomical unit is the average distance between Earth and the Sun. It is equal to 149,597,870 kilometers. Stars are so far away that even using astronomical units becomes difficult. For distances to stars and galaxies, astronomers use a unit called a light year. A light year sounds as though it is a unit of time because a year is a unit of time. However, it is really the distance that light travels in a year. Because light travels extremely fast at 300,000 kilometers per second, a light year is a very large distance. Astronomers also use a unit called a parsec to describe even greater distances. 1 parsec equals 3.26 light years. Distances in the universe. The solar system is made up of the Sun, 8 planets, including Earth, and many smaller objects. Because of the Sun's pull of gravity, it is the central object in the solar system. All other objects revolve around it. The solar system includes a huge volume of space that stretches in all directions from the Sun. Figure 1. This illustration shows the average distances of planets in our solar system from the Sun. The relative distances, locations, and sizes of the planets are not to scale. The inner planets of the solar system include Mercury, Venus, Earth, and Mars. They are small, dense, and rocky planets with cores of iron. Mercury is the smallest planet, and it is the closest to the Sun. Venus is smaller in size to Earth. For this reason, it is sometimes called Earth's twin. Mars is about half the size of Earth. The outer planets are Jupiter, Saturn, Uranus, and Neptune. These planets are spaced farther away from each other than the inner planets. They are also much larger and made mostly of lighter substances, such as hydrogen, helium, methane, and ammonia. Jupiter, the largest planet, is more than 1,300 times the volume and 300 times the mass of Earth. Saturn is the second largest planet, but it has the lowest density, less than water. Density is the mass of a substance per unit of volume. Uranus is twice as far from the Sun as Saturn, while Neptune on the outer edge of the solar system is 30 times as far from the Sun as Earth. Uranus and Neptune are much smaller than Jupiter and Saturn, but each is still over 60 times the volume of Earth. Figure 2 shows the planet. This illustration shows the planets in our solar system and their relative sizes. The distances from the planets to the sun are not to scale. If you could travel at the speed of light, it would take about 8 minutes to get to the sun from the Earth. It would take about 4.2 years to get to Proxima Centauri, the second closest star. Stars belong to systems called galaxies, which are larger groupings of stars in space. Galaxies are held together by the attraction of gravity. The Sun and Proxima Centauri are only two of the stars within the Milky Way galaxy. The Milky Way galaxy contains hundreds of billions of stars. Traveling at the speed of light, it would take 25,000 years to travel from Earth to the center of the Milky Way. Have you ever seen the Milky Way? It is a band of light that stretches across the dark night sky. It is formed by the glow of the billions of stars it contains. From Earth, this band of light is best seen from dark sky viewing sites. Binoculars and backyard type telescopes magnify the view and reveal individual stars. Unfortunately, for those who like to view the night sky, light pollution in densely populated areas makes it impossible to see the Milky Way even on nights when the atmosphere is clear and cloudless. Galaxies are classified according to their shape: elliptical, spiral, or irregular. Look at Figure 3. Our home galaxy is a flat spiral, pinwheel-shaped collection of stars held together by gravity. The Milky Way is shown in Figure 4. Our solar system is located in one of the spiral arms about 2/3 of the way out from the center of the galaxy. What is called the Milky Way is the view along the flat part of our galaxy. Figure 3a, the M81 spiral galaxy is 11.6 million light-years away. Figure 3b, the Centaurus A elliptical galaxy is 11 million light-years away. Figure 3c, the Zwicky 18 irregular galaxy is 45 million light-years away. Figure 4, the Milky Way galaxy. Our solar system is located in a spiral band about 2/3 of the way from the nucleus of the galaxy. Okay, so they're saying this is our sun right here. There's the nucleus of the Milky Way galaxy, and there is our sun right there. The sun of our solar system. So it is about 2/3 out. Okay. When you look at the Milky Way, you are looking out through the galaxy parallel to the plane of its disk. The individual stars you see dotting the night sky are just the ones nearest to Earth in the galaxy. When you view the Milky Way, you are looking through those nearest stars to see the more distant parts of the galaxy. There are billions of galaxies in the universe. Astronomers define the universe as all of space and everything in it. Galaxies are far apart, often millions of light years. Most of the universe is empty space. At the speed of light, you would have to travel more than 2.9 million years to reach the galaxy closest to ours, the Andromeda Galaxy. The largest galaxies contain more than 1 trillion stars, while some of the smaller ones have only a few million. Measuring distances to stars. Measuring distances to stars. How have astronomers found a way to measure the distance to stars? Astronomers often use parallax to measure the distance to a star. Parallax is the apparent shift in the position of an object when you look at it from different positions. You can experience parallax by extending your arm and holding up your thumb. Look at your thumb first with your left eye closed and then with your right eye closed. Your thumb appears to change position with respect to the background. Just as your thumb appears to move, a star seems to move when compared with more distant stars as Earth revolves around the sun. When Earth is on one side of the sun, astronomers look at the position of the star against a background of stars that are much farther away. Then, when Earth is on the other side of the sun, 6 months later, they look again at the star's position against the same background of stars. See figure 5. Okay, so they're referring to this figure. I'm going to hide some of these windows so you can see. See figure 5 right here. Figure 5. Astronomers use parallax by observing the same star when Earth is at two different points during its orbit of the sun. Okay, so the night sky in January is different than the night sky in July. Distant stars, nearby star, the sun, the Earth in July, the Earth in January. All right, guys. Wait a minute. Where were we? Figure 5. Okay. They measure how much the star's location appears to shift. Let me read this again. When Earth is on one side of the sun, astronomers look at the position of the star against a background of stars that are much farther away. Then, when Earth is on the other side of the sun 6 months later, they look again at the star's position against the same background of stars. See figure 5, which we did. Okay. They measure how much the star's location appears to shift. Then they use this measurement to calculate how far away the star is from Earth. The less the star appears to move, the farther away it is. Okay.